Right. So here in this video, we will discuss about objective itself, objective bits regarding unit 3. Unit 3. So before going to discuss about objective bits, see here first we will discuss about hydropower plant. See, this is dam. So water stored in dam and passes through penstock and fall on turbine. If the water fall on turbine, turbine will rotate. If turbine is rotating, what happen? Rotor shaft of synchronous generator is connected to coupled to turbine. If turbine is rotating, rotor shaft of synchronous generator also rotates. So that we will get electrical energy. Okay, so this is about hydropower plant. Coming to nuclear power plant, here see, this one is moderator, this one is moderator, this one is fuel rod, this one is control rod. Okay, this one is coolant, heat. See how, what is our main aim? We should get heat. How we are getting heat? Using fuel rods. Fuel rods are nothing but uranium 238 and 235. If you use uranium 238 and 235, due to fission, you will get heat. That heat passes through tube, so that here water tube will be getting heated up and convert into steam. So finally the steam will fall on same turbine, so that turbine is rotating. Okay, so everything is same. Instead of water, here steam will fall on turbine, so that turbine will rotate and we will get electrical power. Similarly, in thermal power plant, in thermal power plant, again we will use steam. We will get the steam. That steam fall on turbine, so that turbine is rotating. EMF we will get at synchronous generator. So during by comparison of hydropower plant, nuclear and thermal power plant, concept is same. Here water will apply the pressure on turbine, but in nuclear and steam, the thermal, steam will fall on turbine, means steam pressure, with high pressure of steam fall on turbine, so that turbine is rotating. So concept is same in all nuclear, thermal and hydropower plant. So these three power plants are called, means what are those three power plants? What are those three power plants? Hydro, thermal and nuclear. These three power plants are called conventional power sources. Conventional power sources. Power plants. Conventional power plants. Conventional. This is also called non-renewable energy sources. Non-renewable energy sources. Energy sources. So what are the conventional sources? What are the conventional sources? It is nothing but hydro, thermal and nuclear. What are the non-renewable energy sources? Non-renewable energy sources. This is also hydro, thermal, nuclear. Okay. But what are the non-conventional energy sources? Non-conventional energy sources. Here non-conventional energy sources are, see, solar and windmills. Windmills. Here I will use induction generator. Here I will use induction generator. But in hydro, thermal, I will use synchronous generator. But in windmills, I will use induction generator. Why? Because there is no, we will not get constant speed in windmills. So if you use synchronous generator, you should maintain constant speed. But wind velocity is always means always not maintain constant, same velocity. So that I will use induction generator. Okay. So next, solar. So these are the conventional sources. Solar and windmills. These are the conventional sources. So solar cell is nothing but, see, this is glass, this one is metal finger electrode, and this one is P junction, this one is N junction. See, here whenever the light fall on the glass, what happen? Same light will uh, fall on P junction, PN junction. So that electrons in P type, holes in N type, these are moving oppositely. So that electrons are moving away from the N type and holes are moving away from the P type. So that depletion region in between P type and N type will break down and current passes through P type and N type. Initially, there exists depletion region, means initially there exists depletion region. This is initially there exists depletion region. Okay, circuit is open, so that current is zero but voltage is maximum. This is open circuit. Voltage is maximum but current is zero. But whenever the light fall on the means glass, what happen? These electrons are moving in opposite direction, holes are moving in p type. So due to movement of these electrons, depletion region will break down. So if it is breakdown, what happen? High amount of current passes through the semiconductor material. So I is maximum, but what is the voltage? If it is shorted, voltage is zero. So at this point, voltage is zero, but current is shorted. So in between, these are the characteristics of VI for solar. Okay. So here P type, N type. Whenever the light fall on the PN junction, what happen? Depletion region will break down, so that we will get short circuit characteristics. So this is about solar cell. Okay. So working, uses, everything I mentioned here. Generally, where I will use solar, generally it is used in artificial satellites and electrical energy in cooking foods, calculators, wristwatches, electric power in remote areas, power traffic light signals. There I will use conventional. So these are the differences between fuse and circuit breaker. See, what is the difference between fuse and circuit? So, okay, before going to fuse and circuit breakers, till now what we discussed? Conventional energy sources, non-conventional energy sources. What are the conventional energy? Conventional energy sources are also known as non-renewable energy sources. Non-renewable energy sources. This one is renewable energy sources. So what are the conventional energy sources? Hydro, thermal, nuclear. These three are coming under non-renewable energy sources. But coming to renewable energy sources, solar, wind. So conventional energy sources are also called as non-renewable energy sources. Non-conventional energy sources are also called as renewable energy sources. See, what are the examples for non-renewable energy sources? Hydro, thermal, nuclear. What are the examples for renewable energy sources? Solar, wind. So, most of the power plants, used in India. Which type of power plants are mostly used in India? Hydro, thermal, neutral, nuclear, solar, wind. Which one is correct? Option A, hydro. Option B, thermal. Option C, nuclear. Option D, Solar. Option E. Wind. Which one is correct? Thermal. Thermal. Thermal power plants are mostly used. So this is about conventional and non-conventional energy sources. Of course, fuse and MCB. So what is the main difference between fuse and MCB? Fuse. If overload currents passes through the fuse, what happen? Automatically it will melt. But coming to MCB, what happen? It will sense the overload and open the circuit automatically. And in fuse, we have to replace the fuse if it is damaged. But coming to MCB, you can switch on again. No need to replace copper lead. That is the main advantage. Because again by using knob, you can switch on in MCB, but in fuse, it is not possible. Time taking. But here, instantaneously can switch on. And this one is based on overload, it will damage. Fuse will melt out. But coming to MCB, automatically shut off. Here you will use the relay. Understand? So, and here fuse, we have to replace the copper lead. But in MCB, no need to replace it. Time saving. So, these are the advantages of MCB. Okay. So, this is about, these are the, I hope these are the important bits regarding third unit. Thank you.